Yeah, Jessica, we have a YouTube channel now, so that is super exciting. Okay. All right. So welcome, everyone. Welcome to our 11th Phoenix Crypto Meetup. I can't believe it's been 11 already. I'm super excited for this one just because I think it's very relevant. We've already sort of gone halfway down the road for Ethereum 2.0, and we have a lot of exciting updates that are coming up as well. So this session is all about breaking down Ethereum 2.0. Definitely a long-awaited upgrade. And so we're going to be breaking down some of the harder concepts and giving you a high-level overview, just so you can understand what's going on with this. It gets pretty complicated pretty quickly. And here's our agenda for today. Of course, we'll just do our usual welcome to Phoenix Crypto. If you haven't joined us yet, so happy you're here. I'll be giving you a quick overview of our community, sort of what we're all about. And then our middle section, we're going to be talking about actually breaking down Ethereum 2.0. And I think Amelia, when she joins, both of us will be presenting some of the slides. And of course, at the end, we'll have a Q&A. If any questions, you can drop them throughout the presentation in the chat. And then at the end, we'll also just answer any questions as well. And then at the end of the session, so we've been doing this for the last couple of meetups where after the official programming, anyone who wants to stay and chat, I can take everyone off mute. You can share your video if you want, and we can just hang out and talk about crypto or anything else. So we're going to try that out again today. It's been a really fun way to build community. So hopefully you can stick around for that. And again, welcome to Phoenix Crypto. If you haven't heard of us before, we are a chapter on the Codecademy network. There's a bunch of other chapters related to all sorts of things, technical, coding, and we just happen to be a chapter that revolves around crypto. So our sessions usually, we have technical workshops. We sometimes interview people who work in crypto professionally. Basically, we just talk about all things crypto because it's a really exciting space to be in right now. So if you want to connect with us or get more involved in the community, you can follow us on Twitter at Phoenix_crypto. And then to actually join the community, and I think everyone who has a link for this has already done that, but it's at the link at the bottom, community.codecademy/PhoenixCrypto. That's where you can see all of our upcoming events and RSVP to those as well. We also have a Discord, which I promote shamelessly, but it's really awesome. So if you want to have really interesting conversations with people who are also super into crypto, definitely feel free to join that. I dropped the link in the chat, but I'll do it again after the presentation as well. We have so many awesome things happening in this Discord. We have discussions, on trading, crypto, Ethereum. We also have an Ethereum gas fee tracker and just a general crypto price tracker. So very functional as well. And of course, I have to shout out one of our members, David. He posts a really funny crypto meme. So yeah, it's definitely a really good and welcoming place for anyone who wants to talk about this stuff. Our community also sends out newsletters, we have blog posts, and we're also piloting a new sort of talk show / podcast that we're hosting on our Discord called Crypto Bites. And I believe we have an episode next week, so join our Discord to get more details on that. All right, so that's a little bit about our community. Hopefully you can stick around for our future events and join us on Discord. All right, so now we're going to get into this session. And before we talk about Ethereum 2.0, I just wanted to give a quick primer on Ethereum 1.0. We assume that most people here, understand what Ethereum is, how the blockchain works, but we're going to give, sorry, there's a dog barking. We're going to give a quick primer in case you're not super familiar with it. So this is just the basics of Ethereum 1.0. It's a blockchain protocol, so similar to Bitcoin, but just very different in the sense that it's more of a general purpose, all-purpose blockchain. It was founded by Vitalik Buterin in 2013, and then it was actually launched in 2015. And I have a link to his Ethereum white paper here. It's pretty dense, but if you really want to understand what this whole project is, then I would definitely recommend reading that. And essentially, people describe Ethereum as like a giant world computer made up of individual nodes or individuals with computers running this Ethereum blockchain software. And that whole system is called the Ethereum Virtual Machine, or EVM. And it's based on smart contracts, which are essentially just pieces of code that can execute on this general purpose blockchain, really removing humans from the equation entirely. And currently, Ethereum 1.0 runs on a proof of work consensus mechanism or consensus algorithm, which is how the network actually gets secured. And transactions that are added to the block, we know that they are accurate and not fraudulent. And just as Bitcoin is a native currency of the Bitcoin blockchain, Ethereum also has a native currency called ETH, which I'm sure you all have heard of. And then one other interesting concept with the Ethereum blockchain is this concept called gas, which is essentially just units of computing power. So of course, you get transactions added to the blockchain, it takes some sort of electrical power, computing power, and that's just called gas, and you have to pay for that. So I'm sure, if anyone's tried to execute a transaction, the gas fees have been through the roof because the current network is pretty clogged right now. So it just takes a lot more computing power to get things posted. And of course, ETH1 has all those qualities that we really like in blockchain. So censorship resistant, permissionless, decentralized, secure, all that good stuff. So this graphic here, this is just a visual representation of what sort of our traditional system and finance is like, and then what it is on Ethereum. So I think it's a good example. So now if you wanted to buy a house, you'd have to go through so many middlemen and third parties, real estate companies, brokers, lawyers, insurance companies to actually get what you want. But with Ethereum, pretty much removes the middleman entirely and replaces it with code. So if Alice wants to buy a house, she can just deposit some cryptocurrency inside a smart contract. The transaction gets validated. If she has enough funds, it executes, and then there you go. She can get her asset that she wants. That's a pretty gross simplification, but that's essentially, the nuts and bolts of Ethereum. All right, so now that we have the groundwork for Ethereum 1.0, now we're going to get into, what exactly is Ethereum 2, also called ETH2, also called Serenity. There's been so many names for this project, but, it was actually ideated right when Ethereum was first being launched. So this is something that's been in the works for a while. It's been researched extensively. And when Vitalik was thinking about where he saw Ethereum in the next 5 to 10 years, Ethereum 2.0 was his roadmap, essentially. So we're going to dive into this now. One real quick note, most of the graphics in this presentation are actually from the Ethereum Foundation, and they're really awesome. They have really cool artists working on this. So if you're interested in seeing more of them, you can go to the Ethereum Foundation website. So just wanted to give that a shout out. So I think an important question to ask when talking about Ethereum 2.0 is, why do we even need this? Like, ETH1 works if you want to execute a transaction right now. You can. It might cost you an arm and a leg, but it gets the job done, and you can be sure that it's going to be secure and accurate. But there's a couple of different reasons why we need ETH2. And of course, it goes back, you have the famous scalability trilemma diagram here with scalability, security, and decentralization. And the goal is to build a blockchain that hits all three of these, but it's really hard because, do you want to make your blockchain secure and scalable, but not as decentralized, or vice versa? And so there's a lot of reasons why we need Ethereum 2.0. The first one, again, goes back to gas fees, is scalability. ETH1 just has not scaled that well because there's been a lot of transactions that are happening on it. The network is getting clogged, and it just doesn't have the bandwidth to support all the activity that's happening on it, which of course is increasing gas fees and just making the network not as efficient as it could be. So Ethereum 2.0 aims to solve this by being more scalable. The next is security. Of course, ETH2 wants to maintain the decentralized nature of the ecosystem. And going back to decentralization, one of the problems with ETH1, because it has a proof of work consensus algorithm, that's leading to it becoming more centralized. Like, I'm sure you've heard the term mining farms or mining pools. So in the current model, it just takes a lot of computer power and electricity to even secure the network. And so that incentivizes these larger centralized pools to form to actually validate transactions, which goes against the whole principle of decentralization. And Ethereum 2.0 is going to change that based on their consensus mechanism, which we'll get into in a bit. And finally, sustainability, which has been on the forefront of everyone's mind and on Elon Musk's tweets. It's no secret that mining does have environmental consequences, and I haven't done enough research to know exactly what that is, but it's not great. And so Ethereum 2.0 wants to make that better and lessen the environmental impact of this blockchain. All right, so that's some background on why we need Ethereum 2.0. And I wanted to share a picture of sort of the big picture of the Ethereum 2.0 upgrade. So just giving you a timeline. And this picture comes from the Ethereum Foundation website. So as I said, Ethereum 1 was launched in July of 2015, and we've just sort of been using this blockchain ever since for about 5 years. But in December of 2020, that's when the first phase of Ethereum 2.0 already launched. So we're already like in the Ethereum 2.0 upgrade. And the first part of it, which is called the beacon chain, that we'll get into, was successful and it worked. So, that's a really positive sign for, I think, Ethereum 2.0 being successful in the future. And the next phase, which is called sharding, it's supposed to happen sometime in 2021, maybe early 2022, but no one really knows. It's just sort of being developed right now. And then the final phases are going to happen in 2022 or even later than that. So the first part, the first phase is down, it worked, but everything after that is just a little more, up in the air. But there are a lot of people working on this project, which leads me into, so who's actually building ETH2? I just wanted to cover this real quickly because when I think of Ethereum, I just think of Vitalik because he's a meme and he's a genius and he's just sort of the face of the Ethereum project. But there's actually a lot of other people who are building out ETH2. And here's a couple on the slide here. So for example, Prismatic Labs, they're working on proof of stake. Of course, the Ethereum Foundation is doing a lot of work, and there's a team of developers working on this around the clock. Some other ones include Parity, ChainSafe, Harmony, Status. So just wanted to put this out here. It's not Vitalik building the whole thing. That's too much even for him. So there's a whole team of people making this work. All right, so this leads us into the different phases of Ethereum 2.0 because, it's actually broken up into separate phases, which is how you identify where we are sort of in this ETH2 upgrade. And so we're starting with phase 0. It's not phase 1, this is phase 0. And the main parts of it are proof of stake and the beacon chain. And I have underneath here that this is layer 1 scaling. And I just put this here because I personally get confused because I hear layer 1 scaling, layer 2 scaling, and it's just like, well, what does that all mean? But basically, layer 1 scaling means you're scaling the base layer of the blockchain. So proof of stake and beacon chain is scaling the Ethereum blockchain, whereas layer 2, you're trying to scale things that are one layer above it, and we also call that off chain. So just wanted to sort of put that out there in case you had questions about that. All right, so the first part of phase 0 is the proof of stake consensus mechanism. So just to back up, the consensus mechanism is how you basically secure the blockchain, and it's everyone agreeing on a certain set of transactions, saying that they're not fraudulent, and that is what those transactions that are secure get added to the block. So as I mentioned before, Ethereum 1 is proof of work currently, and so the people who are actually running that consensus mechanism are called miners. And the way that system works, you have these miners, they're running really intense computer setups and using a lot of electricity, just all these complicated math problems. And then by doing all this work, it validates that the transactions that they're adding to the block are accurate and there's nothing funny going on with them. So that's sort of what's been done currently, and also Bitcoin uses proof of work. But now with Ethereum 2.0, we're switching to proof of stake. And so instead of being a miner, it's called a validator. So essentially just replacing using intensive computing power to secure the network with staking ETH on the platform. So, okay, what does that even mean? So essentially, if you want to become a validator, you have to lock up a certain amount of ETH in an Ethereum smart contract that is on Ethereum 2 or the beacon chain. So how that currently works now, there's a one-way contract that's on the beacon chain where you put your 32 ETH or more into it, and that is what's backing up the network, essentially. So the idea is that, well, since you have some skin in the game, if you're a validator, that if you violate the rules, you try to propose a fraudulent block, then you get penalized by Ethereum. And so some of that 32 ETH is slashed, it's gone. And there are pretty high barriers to entry, 32 ETH. I actually calculated, if you want to become a validator right now, it's going to cost you about $122,000. So yeah, it's like pretty pricey now. And I think they probably set this this rule back when Ethereum was a lot lower. But yeah, people are putting a lot of money into making this network more secure. And so in exchange for staking your money onto the blockchain, then validators actually earn rewards on that. So they're validating transactions, they're adding them to the block, they get ETH that's mined, and then they also get rewards on top. And I'm actually just going to pause for a second just to see if there's any questions here. Okay, nope. And Amelia is going to join, just FYI, she's having some problems logging in. But that's all right. I'm sure she will join us at some point. And there's one other thing I wanted to mention about, proof of stake and sort of the conceptual economics behind it. Proof of stake only works when the assets that is being staked has value. So if I were to start a blockchain today and you had to lock up like Mackenzie coin doesn't have any value. So like that, the Mackenzie blockchain doesn't mean anything, like it doesn't have value. So I read something that said, blockchains have to go through a proof of work consensus first so that the underlying asset gets value. And then you can switch over to proof of stake because now the assets that is being staked, like ETH, for example, has value. And so they're willing to put in money because they think that it actually means something. So that just makes the whole blockchain more secure as well. So just wanted to say that because this is kind of a weird switch from what we're used to as a consensus mechanism to basically just dropping money into something, and then that's proof that you're going to be an honest validator. So let me go back to questions again. Okay, Brian asks, what's the incentive for locking up your ETH on ETH2? Curious to learn, do you get more ETH if you don't take your ETH off the network? Yeah, so I think the main incentive for locking up your Ethereum on ETH2 now, and actually that goes into this slide here, staking and rewards. So if you get in early, like if you became a validator, like right on December 1st, 2020, the percentage rate, so like basically the interest was super high, and it's all a matter of how much ETH is actually staked on the network. The more ETH that is staked, your interest rate or your rewards are going to be lower, which makes sense, right? There's more people validating, there's more competition, price gets lower. But especially if you got in at the beginning, like you were earning like 22% on your 32 or more staked ETH. So that's pretty considerable. Although it is important to note that this is a one-way contract. So when you were putting your 32 ETH into this contract on the Beacon chain, you can't pull that out until ETH1 and ETH2 actually merge. And we'll go over that in a little bit. But it's definitely, you're taking a high risk here, because if this project fails, then you don't get your ETH back, at least not right away. So that's something just to consider if you were considering becoming a validator. And the note here on the bottom, so the more ETH you stake, the more transactions you validate. I think that's really interesting. So if you decide to stake more than 32 ETH, if you decide to stake like 300, for example, you actually are going to have more transactions that are assigned to you to validate to add to the block. So you are going to get more rewards because you're, adding more blocks. And I think that's a really interesting dynamic, because the theory is that, well, if you're putting more ETH in, that's going to take you need more technology, you need better computers, more power to actually run these transactions. So it's a higher startup cost, but at the same time, you're getting allocated more transactions and you're getting more interest on that, essentially. So, okay, Nikhil asked, do people still get mining rewards from staking? Yeah, so they're not really called, I guess, mining rewards, but when they get a block added to the blockchain, then they get like however much ETH the protocol says. So that's how ETH sort of gets, I don't want to use the word mine, but that's how it gets created. And they're also getting gas fees as well. So, and I know there's a whole, thing on burning gas fees, but that's how they're making money. It's the rewards, and they're just getting ETH. So I thought that was pretty interesting and a good question. Whoops. Sorry. All right, so again, as I was saying, it takes 32 ETH, one-way contract, and non-reversible until the two merge. And the second part of Ethereum 2.0 phase 0, and I mentioned this before, it's called the Beacon chain. And this is a really interesting just engineering architecture right here. So essentially they call it the coordinator chain for proof of stake. So I imagine it just as sort of like the backbone for Ethereum 2.0. It's almost like the mother chain, and then underneath it is a bunch of child chains, which are called shards that we'll get into, but basically to help with scalability. So right now, there's not much functionality with the beacon chain. It was mainly just for validators to basically to institute the proof of stake consensus mechanism. So right now, the beacon chain is just randomly assigning stakers to validate different shard chains, or sort of these child chains. So that's really important because that prevents collusion. So if you got a bunch of nodes, but they're all owned by the same person, and then they all validate one shard, for example, then that's not very decentralized. And so the beacon chain is just randomly assigning validators to different shards. And so right now, this proof of stake network that's living on this beacon chain, it's separate, or it's running in parallel to the Ethereum 1.0 chain that is doing proof of work. So these two things are running at the same time right now. Just the beacon chain isn't functional. It's more just like testing out how the architecture works and just making sure that everything is running smoothly. So I thought this was an interesting stat. So in order to actually launch the beacon chain, the protocol and its rules, it wrote that it needed 16,384 validators. And I just checked some stats on the beacon chain, and there's currently 136,987 active validators. So like way more. So this project has already gotten way more validators and way more staked ETH than what was needed to actually launch the project in the first place. So that just shows you how much enthusiasm there is for this. And again, the more ETH you stake, the more transactions validate. So, and this will make a lot more sense if we talk about sharding as well, which is phase one. And again, this is layer one scaling, so scaling the base layer of the Ethereum blockchain. And again, this hasn't actually gone into effect yet. Maybe later this year, maybe early next year, who knows? But essentially, sharding, I call it like the ultimate scaling solution. And this isn't a new thing. Sharding has been around in computer science for a while, as I understand. And basically, sharding just means partitioning a database into smaller databases. So then when you translate that to Ethereum, it just means splitting up the bigger blockchain, so the beacon chain, into a bunch of smaller blockchains that are all still connected to the beacon chain. So right now they decided to split up the beacon chain into 64 smaller blockchains. I think it made sense mathematically or something, but that's currently what their plan is. And so again, the beacon chain is randomly assigning validators that have deposited their 32 ETH to one of these blockchains. And then once you're assigned to, say, shard 32 or something, then you as a validator are validating transactions and adding them to the block for that shard, for shard 32. So ultimately, this helps with scaling a lot because you're spreading transaction throughput and just efficiency across multiple different blockchains. So it's not all just clogging one larger blockchain. So of course, if you have more scaling, that means lower gas fees, faster transaction confirmation time. So it's just a really good thing to actually scale, because if you want Ethereum to be used, across the world for a bunch of different applications, it has to be a lot faster than what it currently is. And for example, I have this picture here. I tried to buy a CryptoKitty a couple of weeks ago now, and it was a $14 CryptoKitty. Keep that in mind. But the gas fee was almost $5,000, and there was no way I was going to pay that, obviously. But with sharding and with this scaling solution, that's expected to go way down because nodes don't have to download a full copy of the blockchain every time they want to validate a transaction. They only have to look at what shard they're assigned to. And so that just, frees up so much space and just makes transaction throughput just a lot faster. So basically, this is to help with efficiency. And just some more on sharding. So currently, the Ethereum 1.0 blockchain, you can, there's currently 15 transactions per second that are validated or gets added to a block. But with sharding, that's predicted to be in the upwards of like 3,000 to 4,000, maybe even more if they add more shards, transactions per second. So it's a really significant upgrade. And And it's really cool because, you know, if you want to be a validator, it's basically like running just like, I think of like Adobe Photoshop, but it's like running Ethereum software on your computer, because you only need to download a certain subset of the Ethereum blockchain, not the entire thing. Which is why, you know, in the current system, you need huge computing power, and it's just, you know, it's really not feasible for your average enthusiast. And what is this? Get into this a bit later as well, but Ethereum 1.0 is actually going to become one of the 64 shards. So that's really how ETH1 and ETH2 are going to come together. But we'll get into that in a bit. And then this picture here on the right, that's just more of a traditional way of how sharding works. So cylinder on the left, you've got a database with 4 lines in it, and then sharding would basically be just splitting it up into 2 smaller databases that have 2 lines of information each. So, you know, you're actually just splitting it up amongst more areas to help with throughput, scalability, all that stuff. So I think, let's see, Amelia, are you here? Oh, Amelia's here. Okay, awesome. Amelia, if you can go ahead and start talking about, she's going to walk us through layer 2 scaling, which again, as I said, is not the same as layer 1. We're just scaling like the base blockchain. This is off-chain scaling. So Amelia, I think I can hear you.
Can you hear me?
I can. Yes, you might talk a little bit louder.
Oh, okay. Yeah, sorry
You're good. I
about
can hear you.
missing the intro just now.
Oh,
I was having major technical issues. But yeah, so you went through sharding already, which is like horizontal kind of scaling on layer 1. And then we have like layer 2 scaling, which is as the slide is describing, bundling transactions off-chain most of the time. So they have these 5 or 6 different options for it. State channels, sidechain, plasma, optimistic, and ZK rollups. So to go through each one a little bit, state channels are like, let's say that you and I, Mackenzie, want to transact between each other for a set number of transactions. So we would set up like a multi-signature contract between each other, and we would carry on our transactions off-chain, basically, between each other, or I don't know, if like 2 big corporations had many transactions that they wanted to do together, they could do something like this, and then it would be kind of bundled up and pushed onto Ethereum afterwards. And Bitcoin's Lightning Network works like this, where basically you like lock up some portion of like the state, or like the state deposit. And then you can, I guess, finish all your transactions. And then at the end of the month, for instance, push them on to Ethereum afterwards. And that works to expand the network. I mean, to expand the number of transactions, like in a couple tens or a couple hundreds, but not like, you know, like major expansion. And then you have side chains, which is like a whole separate chain that runs on the side of Ethereum. They're usually compatible, but they have their own consensus models and sort of like block parameters to efficiently process transactions. So I think that these ones are like, I guess, again, like you can scale this as much as you want, really, but they're not as secure because they don't have Ethereum's consensus framework running on them. They usually run on like proof of stake or proof of authority. So they're another good option, I guess. But then we have Plasma, which is like smart contracts plus cryptography. And these are like, you could scale this like by 1,000 times, basically. Like you could have that many transactions happening. Basically, Plasma runs on Ethereum, like on top of Ethereum. And when Ethereum gets a little congested, it pushes some of the transactions off into a child chain. And then like the child chain reports back every once in a while to be like, hey, we have a little bit of an issue here. Can you help us solve this dispute? Like it treats Ethereum like a high court, like kind of, I guess, disputes, and then to finally push information back onto Ethereum. And then you have like the rollups, which is when you bundle lots of transactions into one single transaction that can be pushed onto Ethereum. So you have the optimistic rollups, which is when basically you need like the bare minimum information. And you trust that when you're pushing this onto Ethereum, that there is no fraud from like the aggregators and everything. So there are economic incentives to stop aggregators from committing fraud. Whereas the ZK rollups, they're zero knowledge. So they don't need necessarily an aggregator or another person per se to verify or validate. And I think personally, the ZK rollups are the more like exciting, I guess, way of compressing data, because it means that it keeps Ethereum more secure, because there are no other people kind of like trying to come in and validate transactions. So yeah, I think the last thing to mention is ZK Starks. And I think the difference between ZK Starks and ZK Snarks was that the transactions were created by a smart contract themselves, whereas originally ZK Snarks required a person to create the first zero knowledge contract protocol. So again, it's like having a trade-off between having a person actually create the original code, or actually having another smart contract make the code to make the ZK rollups. So those were the differences that I had seen between each layer 2 scaling solution. I don't know if that was helpful or if I was rambling a bit there.
No, that's really helpful. Yeah, layer 2 scaling always sort of mystifies me, because this is just hardcore computer science right here, and just like software engineering architecture. So yeah, thank you for helping with this. And it's important to note that also, like, they're trying to scale by using layer 1 and marry it with layer 2 as well. So it's not really one or the other. And I think currently what they're trying to do, they're scaling layer 1 through sharding, beacon chain, all that stuff. And then I think ZK rollups are going to be the layer 2 scaling solution that they're going to be using a lot. And Vitalik has a really good post on his personal blog about ZK rollups. So they're basically going to use a combination of the two to just like mega scale the Ethereum 2.0 a lot. So Brian asked a question. Can you explain side chains again?
Okay.
Yeah, you can take that one.
So they are Ethereum compatible independent blockchains, which employ their own consensus models and block parameters to efficiently process transactions. So they're like designed to be interoperable with Ethereum. They work in parallel with Ethereum, and the nodes within the sidechain network are responsible for confirming and processing transactions, writing transactions to blocks, and maintaining consensus across the network.
So is there a consensus mechanism? Like, is it also proof of stake for sidechains?
Some of them are proof of stake, some of them are proof of authority, which is something that I had never heard of before, so I need to
Yeah.
learn about it.
Interesting. Okay, and then ZK Starks.
Okay, let's see if I could
Yeah, this
get
stuff is
the
pretty.
okay, I had written down a few notes about this. They are a type of cryptographic proof technology that enables users to share validated data or perform computations with a third party without the data or computation being revealed to the third party. So that's like zero knowledge, scalable, transparent arguments of knowledge. That's what ZK Star is.
What does it even mean? Like, oh my gosh. Right? Some of these names like
Apparently
ZK Starks, ZK Snarks.
yeah,
Kind of blows my mind.
apparently there's some kind of like cryptographic proof where there's like, it's like some analogy to like a curved cave or something. It's like, basically it's saying like, okay, if I were like to try to prove to you how old I was, like if I was trying to get into a club or something, like to prove to the bouncer that I was of age, I could show them my ID card or like the last or like the year on my ID card. So they don't need to know all the information about me. They just need to know like a small portion of the information. And that's what ZK starts and ZK rollups. And rollups in general are trying to do is trying to limit the amount of data that you need to know about a series of transactions between people, basically.
Right.
So
Okay.
that
So I guess you're like rolling up transactions and then just submitting a proof to the actual Ethereum
yes,
blockchain to get validated. Oh, I guess that makes sense. Like zero knowledge. It's more secure.
yeah,
And I guess
exactly.
non-identifiable that way.
Yeah, whereas an optimistic rollup is not necessarily the proof, but just a small chunk of the data itself that's going on. But they're all ways of basically compressing data into much smaller chunks. It's just that each one of these has their own like drawbacks, I guess. Yeah, in terms of like the size of the data that will go onto the Ethereum eventually. So, like state channels is nice because, it's like just between you and me, let's say we're doing the transactions, and then we just push one big transaction onto Ethereum. And the same with the rollups. You have like, you can have thousands of transactions happen between people, and then you just push one small piece of data onto the chain. So it depends on what you're looking for and like how much trust you need between people.
Yeah. That's a great summary. Basically just doing things off chain and just submitting what you need on chain. That's how I understand this sort of at a high level. Okay, we're gonna move on just because we're getting a little bit low on time. So that was layer 2 scaling. Amelia, thank you. That helped me understand it a lot better. So I thought this was a really interesting quote from Vitalik. So basically what I said, the Ethereum ecosystem is likely to be all in on rollups plus some plasma and channels as a scaling strategy for the near and midterm future. So again, combination of layer 1 plus layer 2 to just make an unstoppable Ethereum 2.0 that we can use for everything. So the next phases, phase 1.5 and 2, they're kind of lumped into one, but they separate them out on the foundation website. But basically, it's called the merge. It was originally called docking, but they changed it to the merge. So essentially, this is just where Ethereum 2.0 becomes one of those 64 shards, and ETH 1.0 and ETH 2.0 fully come together. So when ETH 1 becomes one of those shards, it retains the full history and everything that's happened on Ethereum 1.0, so none of that's lost. It just becomes part of the smaller blockchains or databases that are within the larger beacon chain. So with the merge, proof of work is going to be done. It's full transition to proof of stake. So full on validators, no more miners. And this is where the beacon chain actually has functionality. So if you wanted to write a smart contract, execute, or deploy a decentralized application, or if you wanted to transfer crypto to somebody, you can do that now because, as it is right now, you can't really do anything on the beacon chain. They're just sort of in testing mode. But once they merge together, it's going to be the full Ethereum that, we know, except 10 times better because it's going to be a lot faster and the gas fees are going to be lower. So one thing that I thought was pretty cool was that if you are a decentralized application developer, you can actually choose what shard that I guess you want to plug into in the new Ethereum beacon chain. So the idea is that, well, if you run on multiple shards, then it just takes too long, and I think it just clogs up the network versus if you just choose to run on one shard, which I thought was pretty cool if any of you are dApp developers. And so each shard is basically like a mini virtual machine or eWASM that we'll go over in a bit as well. So essentially, the merge just means full beacon chain functionality, and we can actually start using and enjoying all the benefits of the ETH2 upgrade. And I just love this quote. It's from the Foundation website. So, all right, they say, imagine Ethereum is a spaceship that isn't quite ready for an interstellar voyage. And with the beacon chain, the community has built a new engine in a hardened hull. When it's time, the current ship will dock with this new system, merging into one ship, ready to put in some serious light years and take on the universe. This is so dramatic, but I love it because I think it really just exemplifies and embodies what the vision for Ethereum 2.0 is. They really want to make it something that's really unstoppable and that can handle, endless and infinite use cases and just make a really efficient blockchain and efficient system. And the last part of ETH 1.5/2 is transitioning from the Ethereum virtual machine to something called eWASM. And Amelia, do you want to go ahead and take over this one? This one's also kind of weird and complicated.
So yeah, eWASM is WASM itself is WebAssembly, and if you guys are all Code Academy, so you would know about assembly code, which is like one of the layers that basically helps your computer compile code. And it's usually written in like bytecode or like even binary. And this is basically something that does something very similar to that, but for your web browser. So you can now compile or pre-compile like C++, C, and Rust, and Go as well, and Python, using WebAssembly, and then put your JavaScript, CSS on top. And this is helpful for Ethereum because, of course, Ethereum is written in Solidity, which is like kind of like a bunch of different frameworks like put together, smushed together. And they need a way to make the virtual machine that Ethereum usually runs on faster, and this will help basically do that. So instead of compiling somewhere else, it can compile right in the browser. And that's kind of interesting because it adds like this fourth dimension to web development, because usually it's just JavaScript, CSS, and HTML, but now you have WASM as well, which is pretty cool, I think. So yeah, hopefully this will speed up Ethereum and help it to execute much faster. I think that's as deep as I want to go with that because
it's complicated. I saw something that was saying that like the EVM, it was made more theoretically, but then once Ethereum got more popular, it just couldn't handle all the demand from dApps and just like the sheer throughput. But like eWASM is built more for efficiency. Again, like feeding into the whole scaling. So, and does eWASM, is that what allows you to actually write smart contracts in like Python, for instance? Like you don't want to do it in Solidity anymore?
I think that's partially how it works. But like I know that WASM itself is still kind of new and evolving. So It could. It could even get better, but all I know is that it runs in its own virtual machine as well, and I think it uses like a stacking mechanism um, compared to like compared to the current virtual machine. But what's also cool about it is that it's portable and platform agnostic. So like any hardware or operating system that you're using, it understands that basically. Um, and it enables you to like have better security and much like smaller code and all that kind of stuff. It's just more efficient, I guess.
Mm-hmm. Yep, that was my main takeaway. Basically, just like something that can compile Ethereum code, but to your web browser.
Yeah.
Okay, awesome. Yeah, that helps a lot. I know like people throw these terms around a lot, and it's just like what does this even mean? Yeah, but thank you. All right, okay, so moving along to phase 3. This will take 2 seconds because no one really knows what phase 3 is. Vitalik even said it's basically other stuff that we want to add to Ethereum down the line. So not exactly concrete, but I think it's just like some tweaks they're going to make to ETH 2.0 and just add more scalability to it. So like ZK Stars, which you went over, or even like adding more shards if they find that they need to add more. So maybe instead of 64, they'll have 70 or however many they think they should add. And then again, just like further research on scalability and cryptographic methods. So, phase 3 won't really be that important, I think. It's more just like the icing on the cake versus, baking the actual cake, if that's even a good analogy. But those are the 3, or I guess 4 phases of Ethereum 2.0. And Amelia actually made this awesome graphic here. And we shared this in our Discord, and I'm probably going to send it out in another newsletter or blog post as well. And this just is a visual representation of the Ethereum 2.0 upgrade. So thank you, Amelia. This is super awesome. I love this. It definitely is really good reference if you just want to refresh on ETH2. All right, so I also wanted to share some Ethereum 2.0 just like resources. So to even prep for this, like Amelia and I both read a bunch of articles, podcast videos, like the whole shebang. And these ones that I linked here, I thought were really good if you're interested in learning more about this. Just a couple I wanted to call out. CoinDesk actually has a podcast all about ETH2. They're actually like one of their journalists or researchers is running a full node on the network, a full proof of stake node. So that's just sort of like her narrating her journey in ETH2, which is cool. And then I really like an incomplete guide to rollups. It's actually a blog post on Vitalik's website. And just in general, if you want to just, hear it from the horse's mouth, go to vitalik.ca. And that's his personal website. Lots of great information. And then just for sort of a deeper dive on everything we've just talked about here, CoinDesk has a really great Ethereum 2.0 research report. It's not too long, but it really goes in depth on ETH2, and it really informed a lot of our research. And I just put this picture of Vitalik donating a bunch of shit coins to India because that's the world we live in right now, and it's awesome. So, all right, so those are some of our resources. And now we're going to go to Q&A. So if anyone has some questions, please ask. I know someone asked about what are gas fees. A couple people answered this already, but basically it's just the cost of adding your transaction or getting your transaction into a block, because these people that are validating it and saying that, yeah, this is legit, it checks out, like that uses their computing power. So like that's not for free. And yeah, like likening it to AWS is really good. That's a really good analogy.
Yeah, someone asked. Someone asked, is it difficult to become a validator? And do you need
it costs $122,000.
It really does. It's very expensive.
Oh my gosh. Yeah, so Amelia and I were talking about this, like if they want more validators, like they're gonna have to lower that barrier, because that's just insane. Like regular people, even who just want to invest like $10,000 or something, like they're not gonna be able to afford that. So that's a barrier.
I think you can become like a valid, well, you can add your like your Ethereum to a staking pool as well, or a validator pool. Yeah, how does that work? I can't remember.
I think there's just certain companies, like I think they might, there's either like staking, well, there's staking as a service, which is a whole different ball game where like if you want to stake Ethereum, assuming you have 32 ETH, then you can give it to a company who basically takes care of it for you. Like they'll set up your node, they'll essentially take custody of your Ethereum. So it's basically for those who want to get the upside, like they want to get the interest, but they don't want all the technical fuss about it. So like these staking as a service companies take a cut of the rewards. But yeah, there's also like staking pools. I don't know how it works in relation to like, or how it compares to mining pools, but I think you just pull a bunch of ETH and you just have one node, but multiple people get the rewards from the node. Like the rewards are split amongst the participants.
Okay.
Pretty sure that's a thing. I think someone in our Discord mentioned it. Haven't really looked into it though. And then in terms of hardware, I think like I think they want to get to the point where you can just run it on your laptop essentially. But as of right now, like one of my friends actually is a validator and he had to buy, it's called a Nook. It's like this little mini computer that Intel sells. And it's just like, it's like a hard drive essentially, but it can run a node on it. Not even like, I think it can run a full node, but also just like, if you're just validating for one shard, it can run that too.
Yeah, I think someone asked about ZK snarks. So just to go over that one more time. Okay, a snark, which is different to a stark, is so a zero knowledge, succinct, non-interactive argument of knowledge. And I guess I could go through like, okay, so like succinct is like the size of the proof is very small compared to the size of the statement. And non-interactive means it does not require rounds of interaction between the prover and the verifier. And it's secure only for provers that have like bounded computation resources, I guess. I guess the other thing to add to that is that it's not possible for the prover to construct a proof without knowing a certain so-called witness for the statement or like a small amount of knowledge at the beginning. So that's what the snark is all about.
We need like we do a separate session like what the heck are ZK snarks and ZK starks like. We need Vitalik as a guest speaker. That's what we need.
Well, yeah, because they each have their own algorithms that they work on as well, like series of algorithms as well. So it really gets it starts to get a little complicated. You don't have to go far before it gets complicated.
Yeah, I think like that's the most complicated part of it. Like I think just understanding the overview or like the high level overview of ETH2.
Yeah.
Like that sort of makes sense, but when you get into this deeper stuff, like, ooh, okay, Mihail asks, will gas price be reduced until, or will gas be reduced until Ethereum 2.0? That's kind of hard to say. Like the price of Ethereum gas, it really just depends on how much demand there is in the network. So right now it's just really high.
Yeah, in the last few days, I got the gas bot working.
Yes, we have a gas bot on our Discord. Check it out.
Yes, but the gas bot, like you can see the gas price fluctuates throughout the day quite, like I guess quite a bit. So, like at the beginning of the day, so this is really early in the morning, it will be like maybe like 100 way, and then it will go up to like 300 and something in the middle of the day. So like you can see like traffic is increasing until like a peak during the day and then it goes back down at the end of the day. So I mean, if you want to track your gas prices and do your transactions, at low peak, low flow times, that's a good way to get around the gas prices currently. But with ETH2, we're all hoping that these gas prices go down, but like,
Yeah,
so,
I can buy my crypto kitty for like $5
yeah,
worth of gas fees, or not lower, if not lower.
exactly. Like
I
gas
put a
fees
link
of
here.
tens of dollars, not hundreds of
Yeah.
dollars.
Oh my gosh. If you actually want to have like, I have a Chrome extension. It's called the Ethereum gas price tracker. And it's just like an extension in your browser, or you can have it in Brave or whatever. And when you click on it, it tells you like if you want to have like a fast transaction, a standard, or a slow transaction, how much it costs. And it updates like every minute or something. So like it says right now, if you want to, I guess each GUI would cost $8. So it just depends how many GUI your transaction cost. So that's pretty interesting if you actually want to like really track it on a granular level. Yeah, great questions though.
Good question. Did we miss any questions from above? Let me check.
See, I know we're running up on time. You can always just reach out to us. And basically, like, there's a lot of information online. It just comes down to like doing a lot of research and distilling it. Which is, you know, a lot of it's kind of confusing though. Let's see. I think.
Yeah, there's one here. What's the incentive for locking up your ETH? I'm curious to learn more. Do you get more ETH if you don't take your ETH off the network?
Right. So I'm trying to find that question. The incentive for locking it up is that you earn rewards, essentially. So when you lock it up, especially when the earlier you lock it up. So if you lock it up now, you're just going to have a lot more interest because it's a lot more risk because you can't just pull it out. Like you can't pull out your staked ETH until ETH1 and ETH2 merge, and you can actually like pull it out of the contract. So yeah, if you keep your ETH in the network and you are an active validator, then you're going to make a lot more than if you go offline and you're a validator, your ETH gets slashed, like it gets penalized. So either you're all in or you're all out because you're like the network is automatically going to take your ETH and it's an incentive for you to actually be an honest validator.
Yeah. Other people can slash you too.
Yeah, so let's see. That was an awesome question though. Yeah, all this stuff is just, it's so new, but it's so fascinating. Like it takes such a long time to wrap your head around. Okay, so I think that's it for questions. Again, if you have any others, please just reach out to us. I just want to plug our next meetup, which is like May 27th, next Thursday, or sorry, 2 Thursdays from now. And we'll be teaching everyone how to experiment with DeFi dApps using testnet. So in case you didn't know, you can get like fake crypto and deploy it into some popular dApps like Uniswap, Aave, Oasis, which is made by Maker. And some just like play on their test nets with fake crypto just to see how it works. So you don't have to actually like put up your real money until you have played around with it and know what you're doing. So be more of like a workshop, but it'll just be like showing you how to set it up, how to get test nets on your MetaMask, and also just sort of like a workshop on how to actually use some of these dApps. I've used Aave, I've used Oasis, haven't used Uniswap, so I'll be looking into that. But yeah, if you're actually looking to get some skin in the game, this is a great place to start. So again, join our Discord. And yeah, I think that's all I had. Amelia, do you have anything else?
No, that's all. I mean, the Discord is really cool. Come and have a look.
Yes. Sorry, I'm such a nerd. Okay, I'm gonna stop recording now. All right.